Alrighty, today we're going to be talking about scientific notation. Scientific notation is something we use when we want to write numbers that are very big or very small. So they have a lot of decimals either before or not a lot of decimals, a lot of zeros before or after the decimal. All right. So, a number that is written in scientific notation, let me make this a little bit bigger here. Oh, goodness. Is written as a product of a factor and always a power of 10. A number that is not written in scientific notation, we say, is written in standard form. So you'll be asked to switch between scientific notation and standard form. So let's take a look at what scientific notation looks like. Scientific notation is a number times a multiple of 10. So A, which is this number, has to be greater than or equal to 1 and less than 10. And N has to be an integer, which means it can be negative, right? So we're going to see what that means. Very, very small, tiny, tiny numbers use negative exponents. And really, really big numbers with lots of zeros at the end use positive exponents. All right, so let's look at some examples here. If we want to write this number, which is currently in scientific notation, over on the left, and put it into standard form, which is over on the right, we would move this decimal 3 places to the right. Because a positive exponent means we're making a big number, and to make a big number, we'd want to move that decimal place to the right. So if we have 2.23 times 10 to the third power, we're going to move it 1, 2, 3 places, and if there aren't enough places, we're going to add zeros, and that's how we get 2300. For the next example, we have the same number at the beginning, but our exponent is negative, which means we want to make a small number. And to make a small number, I'm going to take that decimal and I'm going to move it 3 places to the left. And just like the other example, if there aren't numbers in those places, you're going to add zeros, and that's how we get 0.0023. Most people put a 0 in front of the decimal also. So we would move that decimal 3 places to the left. All right, so let's try some. This negative means I'm moving the decimal to the left. So if I have 3.25, I'm going to move it 1, 2, 3, 4, 5 places. If I don't have enough places, I'm going to add zeros there. My decimal will be right here. So that equals 0.0000325. For the next example, let's switch colors so we don't get them mixed up. This 2 is positive, so I'm going to move it to the right twice. So where is the decimal in the whole number 4? It's at the end. And then we're going to need a couple more zeros, so I can move it 2 places over, and it becomes 400. For the next one, we're going to move it 1 place to the left, right there, to make it 0.13. Stick a 0 in front of it. Most people like doing it that way. And then we have a 7 that's positive, so we're going to move the decimal 7 places to the right. 1, 2, 3, 4, 5, 6, 7. And I'm going to put my zeros in there. So that becomes, where will my commas go? Here and here. So it'd be 18 million. You use scientific notation a lot in science because we have numbers that are so big and so small in science. All right, so that's going from scientific notation to standard form. Now let's go from standard form and put it in scientific notation. So remember that the number that's being multiplied by a power of 10 has to be a number between 1 and 10. So we look at this 700,000 and think, where would I have to put the decimal to make that a number between 1 and 10? Well, it would have to go here because 7 is a number between 1 and 10. So I'm going to have 7 times 10 to some power up here. I should maybe make it a box and not a circle because it looks like a 0. So first of all, I know it's going to be positive because this is a big number. And let's think about how many places we would have had to move that. We'd have to move it 1, 2, 3, 4, 5 places to get it back to its standard form. All right, let's look at the next one. We would want to put the decimal here to make it a number between 1 and 10. And then when we're thinking about what our exponent is going to be, I know it's going to be negative because this is a small number less than 1. And I would have to move it 2 places. So negative 2 is going to go there. So you would write 4.5 times 10 to the negative 2. Not a box there. I'm just putting the box to show that we have a missing number we're looking for. So this one, I would put my decimal right here to make it a number between 1 and 10. So 3.2034. You don't have to write those 3 zeros after. Once you have all zeros left at the end, you can drop them. And I know this is a big number, greater than 1, and I'd have to move the decimal 1, 2, 3, 4, 5, 6, 7 places to get it back to standard form. And one last example here. I'd have to put the decimal right here to make that a number between 1 and 10. It's a small number, so my exponent's going to be negative, and I'd have to move it 1, 2, 3, 4, 5 places. So that's how you go from standard form to scientific notation. Thanks for watching.